Welcome back to Introduction to Astronomy, and in the previous segment we were talking about what speed is. And so you might be wondering, well, how big can speeds be and how small can they be? And so here is some typical speeds in meters per second. And so you can see there how fast your hair grows, how fast a glacier travels down a mountain, and then at the other end of the scale, you see that speeds can be very, very large, but there is a ultimate speed. And what do you think that speed is? So the ultimate speed is going to be the speed of light, and so that's going to be 3 times 10 to the 8th meters per second. And so later in the course, we will discuss the speed of light. So now we want to talk about a concept that's related to speed, but it's a little bit different, and that's going to be acceleration. So you have in your car a device that causes acceleration. And so what is that device? The accelerator. So when you press down on the accelerator, you are accelerating. So what does that mean? So you know what happens. So when you press on the gas pedal, what happens to the car? It goes faster. Okay, so acceleration changes your speed. So if you look at that formula, A stands for acceleration, and V stands for speed, your velocity. But what's that triangle thing in front of the V? So that means change. Acceleration changes your speed in a certain amount of time. So that's what the T is. So if you look at this one and then go back and look at the one for velocity, isn't technology wonderful? So if you go back and you look at the one for velocity, you see it's R over T, whereas the acceleration one, it's got to work. All right, there you go. So it's going to be V over T, the change in your velocity over time. So what I want you to do is there's a little simulation that I want you to take a look at. And so this is called PhET. So you're going to go to Google, type in the word PhET, the moving man, and then open up that simulation, and you're going to see a picture that looks kind of like this, where you've got this guy in a business suit and he looks very dapper, and underneath him is a thing that says position. And so if you move that slider back and forth, that just changes where he's located at. So we don't really care about that. So you can keep the position on 0. So what I want you to do is give him some velocity. So move the velocity slider and keep the acceleration 0. So don't change the acceleration slider, but give him some speed and then press the go button, the start button. And you will see that he will start to move across the screen. Okay, now hit the reset button. Okay, so put him back in the middle there. And this time, what I want you to do is give him some speed like you did before, but this time give him some acceleration as well. Okay, how would you describe the way he walked when there was no acceleration versus how did he walk when there was acceleration? So you should have noticed that he walked at a constant speed if there was no acceleration. So that's very important. When there's no acceleration, there's no change in speed. So that means whatever speed he starts out with, that's the same speed he has as he walks across. On the other hand, when you gave him acceleration, Did you notice that he walked faster? Okay, because his speed was changing. That's what an acceleration does. Accelerations change your speed. Now, I also want you to investigate. Give him a positive speed, but give him a negative acceleration. So you're going to move the bottom slider to the left there and give him a negative acceleration and a positive speed, and then start it and see what happens. So you'll notice that he starts to move to the right, but then he slows down and he reverses, and then he starts going back the other way. So you can think of acceleration as a master control knob. Whatever your acceleration is, that's going to control your speed. Even if you've got a speed of 1,000,000 miles per hour, if you've got an acceleration of -1 mile per hour squared in the opposite direction, eventually you're going to come to a stop, turn around, and then start going backwards. Okay, so let's investigate this. I'm going to take this pen and I'm going to throw it up into the air, and I want you to observe, what does it do? Okay, did you notice that? It went up and it turned around and then it went back down again. I wonder why it did that. Well, I guess there's no reason for it. That's just what pens do. No. Okay, the speed was originally in what direction? That way. Came to a stop and then became negative. It started going back down again. So what must be in this room even as we speak? A acceleration, a negative acceleration. And what do you suppose is causing that acceleration? Gravity. So do you think we've got a word for it? Yeah, the acceleration due to gravity. And so we'll learn a little bit more about that later. But gravity, a force, is what causes the acceleration. And then the acceleration in turn determines how fast you're going and where you're located at. So we could do a math problem with this, but it's not necessary. So we could actually take numbers and plug it into that formula, but I just want you to know what the concept of acceleration is. Okay, and then here are some typical accelerations in meters per second squared. Now, where did that come from? Okay, so let's go back. Acceleration A was equal to the change in velocity over time. Okay, what was the unit for velocity? Meters per second. And then what was the unit for time? That was the second. So when you put this together, this second and this second, they go together to make seconds squared, and then the meter is still on the top. So the units of acceleration are meters per second squared. So here's some typical accelerations for you, just to look at, so don't get too worried about it. And when we come back, we are going to now talk about forces.